In this chapter 11, we are going to study streams and exception handling. From this PowerPoint, we are going to study exception, and the file streams will be discussed in a separate PowerPoint. So exception handling provides a flexible mechanism for passing control from the point of error detection to a handler that can deal with the error. This is very similar to GUI programming that we have done so far. We set event listener, but that listener is called whenever you click a button or choose a menu, something like that. So when you set up exception handling, so it works very similar to GUI event handling. So when you detect a collision error condition, you can throw an exception, and that exception can be handled in a separately. So how do you throw an exception? Is you need to create an exception object, then use a keyword throw, then you are throwing the exception. So the exception, to be an exception, the class should be a descendant of a certain type that is a throwable. So we are going to discuss that in detail in the following slides. So exception is a thrown method is terminated immediately, and then execution continues with the exception handler. So this is the syntax how to throw an exception. Here the Java keyword throw is used to throw an exception. There's another Java keyword throws, which is quite different. So here is a singular, just a throw, not throws. And then specify the object to be thrown, and this object should be a descendant of a throwable class. So here is the hierarchy. The top of the hierarchy is a throwable. To become an exception object, it has to be a subtype of a throwable. Of course, a throwable is a subtype of a cosmic superclass object. Throwable has two subtypes, error and exception. And the exception has many subtypes. One of them is a runtime exception. And then here we have some color code. So exception, and any children of exception except runtime exception, those are in a dark color. And here are descendants of IO exception. The reason why we do color coding is that when you write the program and that program throws an exception of a type in a darker colored one, you need to handle it. And then others you don't have to handle it. So we are going to study detail in the following slides. So at this moment I want to remember that exception is one of the throwable type, and the exception has many children types. One of them is a runtime. Except for runtime, they are all dark colored. So how do you catch an exception is using try and catch block. So try block specifies the program to be executed, and then if one of the statements throws an exception, then one of the catch block will be invoked, and then you can have many catch blocks, and then based on the type of the exception thrown, the corresponding catch block with a matching parameter will be executed. So this is very similar to method overloading. Consider catch. Those are as a method name. Then you have different parameters. So we have a method overloading situation. So for example, at this line, if exception is thrown out from the next method call, and then if the exception thrown is of a type IO exception, then this catch block will be executed. If the exception thrown, the type is matching with the number format exception type, then this catch block will be executed. So the execution flow is as follows. In try block, if exception is thrown by one statement, for example this, then uh, the program execution jumps into matching catch block, and the rest of try blocks are skipped. If no exception is thrown in try block, then all catch blocks are skipped. That's the execution flow when you have a try and catch block. So the previous example, you can get some of the exceptions thrown if something goes not correctly. So file constructor, in the previous example, we have a file construct is called a file constructor throws a null point exception. So how do you know that? Using the Java API document. So here, Java SC8, we use a file, then file class document is here, and then one of the constructor, the one being used is the file constructor with a string argument. So here says throws a null pointer exception. So when you use a file constructor, null pointer exception could be thrown if the path name argument is null. So what it means is that at this moment, when you call file constructor, if you didn't assign the value into file name but it was null, then exception is thrown, which is a null pointer exception. R is missing, there is a typo. The for scanner constructor takes one file object. So if you take a look at Java SE8 scanner constructor, which takes one file object as an argument, throws a file not found exception. So this line may throw null pointer exception out of a file constructor or a file not found exception from scanner constructor. So depending on which one occurs, the catch block will be invoked. Here, scanner constructor throws a file not found exception. File not found exception is a subtype of IO exception. So here, out of two catch block, the first one is a matching in terms of a method of loading rule. Subtype could be assigned to supertype, so the first catch block will be thrown if something goes wrong with the scanner constructor. But here, file constructor throws null pointer exception, but we don't have a null pointer exception. And then if null pointer exception is not a child type of a number format exception, or it's not child type of IO exception, there's no matching catch block, then we have an error condition. So what happens if exception is thrown? If a file not found exception is thrown, that is a subtype of IO exception, so the first catch block will be executed. So a Java API document shows the one. So file not found exception is a subtype of IO exception. So we can verify that from Java API documentation. So if a number format exception occurs, if I go back, we have a catch block for that, so it works. But here, scanner, no such element exception is from next method call, but we don't have a such, so we have some error condition there. So catch block, a try block is a having those format. So each catch clause contains a handler. You can provide your own exception. For example, you can throw by creating an exception object. You can throw your own exception as well. So now we have two terminology regarding exceptions. So in hierarchy, if I go back, throwable is top of the hierarchy. We have two subtypes, error and exception. And the exception has many, and one of them is a runtime exception. So the meaning of this hierarchy is explained here. So three categories. Internal error. So error type is internal error. It's a out of a memory or Java virtual machine error. Those are error type. And then descendants of a runtime exception, which is one of IO exception child. Some example under runtime exception is index out of bound exception or illegal argument exception. And these cases are all under runtime exception indicate that your code has error, meaning that you are responsible for fixing it. And those are called the unchecked exceptions. The unchecked exception, the terminology is any exception of a runtime exception type or it's a descendant type. For example, index out of bounds and so on. And then all other exception means subtype of IO exception except runtime. So let me show you the hierarchy again. So dark colored one, subtype of exception except runtime. So those are called checked exception. The checked exception indicate that something has gone wrong for some external reason beyond your control. So what it means is that your program is correct, logically correct, but external situation does not cooperate to your program. That's the meaning of a checked exception. So one of the example is IO exception. So checked exceptions are due to the external circumstances that's beyond the programmer's control. But in Java language, the compiler checks that your program handles these exceptions correctly or not. So if you don't handle problems that could occur under checked exception cases, you have a compile error. But unchecked exceptions are your fault, so you need to fix it. So compiler does not complain about that. So here is the example. So if you open a file using scanner like that, then scanner constructor throws a file not found exception. File not found exception is a checked exception, so you have to catch it. Otherwise, it's a compile error. And then another way of handling exception is that you can forward the exceptions to the caller of the method using keyword throws. So here is a keyword throws. Using keyword throws, which goes the header part of the method definition, saying that whoever calls this method read the data may throw file not found exception. So the caller should handle the error. So that's called the keyword throws, and this is called advertising the exception. So for example, here in this method, as we know from the previous slide, the scanner constructor may throw file not found exception. The Java rule is that you have to handle it using try catch block here, otherwise it's compile error. But another way of handling exception is you can advertise or you can forward the exception to the caller of the method this way. Then whoever calls this method should do try catch block. Otherwise, compiler will occur. So throws clause that you define in method header definition signals to the caller of your method that may encounter a file not found exception. So caller must decide to handle it, or the caller also could advertise the exception or forward the exception to some other callers. So in general, Java rule or suggestion is that throw exception as early as possible, but catch it as late as possible. If you catch it late, you may have more information as to handling the situation correctly. So syntax example, keyword throws, it's a singular form, it's not throw, it's quite a different one. And then you can define a method that may throw this exception, another exception using comma separated syntax. So another clause related with the exception handling is a finally clause, which is optional though. So finally clause is always executed, guaranteed to be executed. What it means is that if try block throws an exception, then one of the catch block will be invoked. So catch block is not shown here for clarity. But if a try block does not throw any exception at all, then finally clause will be executed. If an exception is thrown within the try block, then we know that corresponding catch block will be executed, and then finally clause will be executed too. So finally will be executed with or without exception being thrown. So logically speaking, you don't have to put this part at all, because if you put out that clause simply outside all try and catch block, which means this is just the following statement after try catch, so this one will be executed always. But by putting finally clause, you are telling that this part is logically related with the try catch exception handling. So in the physical execution order, whether you put finally clause or not, this is anyway executed. So syntax wise, you have a try and a catch, as many catch clause as you like, and then finally, so this one is guaranteed to be executed. You can design your own exception types. So here the example is that you can throw insufficient funds exception. This is your own class definition. Then when you design the exception class, it has to be a descendant of a throwable class, which is top of the exception hierarchy. But depending on which throwable type as a parent type of this one, it becomes either a checked exception or unchecked exception. Remember that if this insufficient funds exception is a subtype of a runtime exception, then this becomes unchecked, so that the user of this part of the code, caller of this part of the code, does not have to do try catch block. But if you have an insufficient funds exception as a subtype of IO exception, then it becomes a checked exception. So the caller of this method should do try catch block, otherwise it will become compile error. So here is an example of your own exception class definition. So if you do extends runtime exception, this class becomes unchecked exception. So the caller of this exception class does not have to do try catch block. So here's an example. Suppose a balance is 100 and the amount is 200. What is the value of a balance after this statement? So exception thrown when amount is less than balance, so exception will not be thrown at all, so balance minus amount becomes the value. So another example, when depositing an amount into bank account, we don't have to worry about the overdrafts except when the amount is negative. Write a statement that shows an appropriate exception in that case. So here is the answer code. When negative, throw an exception. So another self-check, consider the method. Suppose the file with the given file name exists and has no contents that trace the flow of exception. So try block, you open a file and we assume that the file name exists, but content is empty, so at this moment exception will be thrown. And then what exception is thrown? So we need to read the API document. So in object is a scanner calls a next int. So scanner calls a next int method. Here is a list of a method. The next int method throws a no such element exception. The file is currently empty, so no such element exception will be thrown. No such element is runtime exception. That's the information we have. So we don't have a runtime exception or no such element exception catch block. So at this moment we expect the program error occurs. So the scanner constructor succeeds because the file exists, and the next int method throws a no such element exception as we looked up the API document. This is not an IO exception, therefore an error is not caught because there is no other handler. The error message is printed and the program terminates. Why is array index out of bounds exception not checked exception? Checked exception is your program does not have any logic error, only the external situation is not cooperating with your program. But array index out of bounds is the case that your logic has some problem. So this is not checked exception but unchecked, so you have to fix this error.